Welcome to my presentation. This presentation is part of the playlist Integrals of Exponential Functions. In this presentation, we are going to solve some example problems related to integrals of exponential functions. Let us look at an example problem. Let us say we want to evaluate this function, integral 5e to the power of 5e to the power of 2 minus x dx. Okay, we are going to use the exponential rule to solve this example problem. Okay, so let us substitute u as equal to 2 minus x. Let us substitute u as equal to 2 minus x. Now, u is a function of x. We're going to differentiate u with respect to x. Du by dx is equal to minus 1. Why? This is the way. When we differentiate a constant, it is going to be 0. When we differentiate x, it is going to be equal to 1. So d by dx of minus x is equal to minus 1. So I can rewrite this as du as equal to minus 1 dx. I brought this dx to the side of the expression here. If I have to express it in terms of dx I can write as equal to 1 over minus 1 du, or 1 over minus 1 du is equal to minus 1 du, same as that. Now we can substitute u as equal to minus 2x and then dx as equal to minus 1 du into the given example problem, and then use the rules of integration and solve this example problem. Our example problem is as shown here, integral 5 e to the power of 2 minus x dx. So integral 5 e to the power of, wherever we see 2 minus x, we're going to substitute that by u as shown here. Instead, wherever we see dx, we're going to write as minus 1 du as shown here. So now, as you can see here, 5 times negative 1 is negative 5, and that negative 5 is a constant, so I pull it outside of the integration process. And then we are left with integral e to the power of u du. We know that integral e to the power of u du is equal to e to the power of u. So therefore, we have negative 5 outside of the integration process. Negative 5 times integral e to the power of u is e to the power of u. And when we finish the process of integration, we're going to add a constant term called the constant of integration, c. So therefore, now we need to express our solution in terms of x and not in terms of u. So therefore, wherever we see u, we're going to replace it by 2 minus x, like that. So therefore, we can write this as negative 5 e to the power of 2 minus x within parentheses plus c, where c is a constant of integration. This is the way we're going to solve example problems which involve exponents using integrals of exponential functions. Let's look at another example. Let's say this time we want to evaluate this function, integral e to the power of x, square root of 1 minus e to the power of x dx. Okay, we're going to use the exponential rule and the rules of integration to solve this example problem. Let us substitute u as equal to 1 minus e to the power of x. 1 minus e to the power of x is what we have under the radical term here. So therefore, differentiating u with respect to x, we have du by dx is equal to d by dx of 1 is 0. d by dx of e to the power of minus x is minus e to the power of x. We have seen that in differentiation process. So therefore, I can write this as du as equal to minus e to the power of x dx. If I have to express this in terms of dx, I can write it as dx is equal to 1 over minus e to the power of x du. Now, we can substitute u as equal to 1 minus e to the power of x, and wherever we see dx, I can write as 1 over minus e to the power of x du into the given example problem, and then use the rules of integration and solve this example problem. So our example problem is e to the power of x square root of 1 minus e to the power of x dx. So wherever we see 1 minus e to the power of x, we're going to substitute that by u, Since that is under the radical term, we're going to put a radical term over the u. So therefore, this translates to integral e to the power of x square root of u. Wherever we see dx, we're going to replace it by 1 over e to the power of x du, like that. So therefore, I can write this as now, as you can see here, we have an e to the power of x in the numerator, e to the power of x in the denominator. So those two terms cancel out. So 1 over minus 1 or minus 1 is a constant. So we're going to take it outside of the integration process as shown here, integral. We are left with square root of u du, like that. So I can write u as equal to u to the power of half. I can convert the radical term into an exponential term to be able to use to be able to apply the process of integration. I can convert the radical term square root of u as an exponential term which is equal to u to the power of half as shown here. So minus 1 integral u to the power of half du. So integrating the function we have minus 1 u to the power of half. When we integrate it, it is going to be u to the power of half plus 1 divided by 1 half plus 1 plus c, where c is a constant of integration. So we can simplify it some more as minus 1 u to the power of 1 half plus 1 is 3 over 2 divided by 1 half plus 1 in the denominator converts to 3 over 2 plus c. So 1 times 3 over 2, when we bring it to the side of the expression, it converts to 2 over 3 times u to the power of 3 over 2 plus c. So minus 1 times 2 over 3 is minus 2 over 3 times u to the power of 3 over 2 plus c. So we cannot leave our answer in terms of u. We need to express our solution in terms of x. So therefore, we're going to, wherever we see u, we're going to substitute 1 minus e to the power of x, right? So therefore, minus 2 over 3, 1 minus e to the power of x, the whole thing raised to the power of 3 over 2 plus c, where c is a constant of integration. This is the way we're going to solve example problems which involve integrals of exponential function. In my next video presentation, we will be solving more examples related to integrals of exponential function.